There is much misinformation, and I'm sorry to say disinformation, about global warming abroad in the land, and I thought it's worth a few minutes to explode some of these fictions about the future of Earth's climate. The first of these is frequently quoted, that 97% of climate scientists believe that human activity is warming the planet. That's not even close to correct. Even going back to 2013 and 2014, before the evidence was so overwhelming, there were 24,210 papers published in the refereed literature that included the term global climate change or global warming in the title or the abstract. Of these, only 5 rejected anthropogenic warming, that is, that humans are causing the warming of the planet. 2 of these were by the same author, only 1 of them was ever cited again. Thus, the real numbers are 4 out of 69,406 authors deny that humans are causing climate change. That's a 99.994% consensus. That's scientific consensus that's overwhelming. The second fiction, really only half a fiction, is that melting glaciers are raising sea levels. We see in the diagram from about 2005 that the Greenland ice sheet, by far the dominant contributor of melting ice on the planet at the moment, is contributing about 0.4 of a millimeter per year to sea level rise. But in fact, the sea levels are rising 10 times faster than that, at 4 millimeters per year. Now, this is not to say that Greenland isn't actually melting. It is. In the 1992 to 2001 period, there were 34 gigatons per year of ice turned into water that flowed into the ocean. By 2012 to 2016, that number had increased 8-fold to 247 gigatons per year. And in 2019, it doubled again to 532 billion tons of ice turned into ocean water in that year, which would have raised the total contribution of Greenland ice to sea level rise to about 1 millimeter per year. But the total is still 4 millimeters per year. And the reason is that fully half of the expansion of the sea is a consequence of the thermal expansion of the water molecules. The water molecules sitting in the water jiggle back and forth, and as you warm them up, they jiggle more violently and they elbow each other apart, and as a consequence, the water expands. Warm water just takes up more space than cold water does. And as a consequence, half of sea level rise would occur even if not a drop of water added to the ocean, because as the temperature goes up, the sea level expands. And here you can see that and how rapidly it's increasing. It was about 1.4 millimeters per year in the period 1900 to 1970, whereas now it's about 4 millimeters per year over the last decade, or 4 centimeters, 1.5 inches every decade. Now, our IPCC global climate models can predict how this will evolve into the future. You can see from 1900 to the present, there's been a rise of a couple tens of centimeters. And you can see going forward that even in the most optimistic scenario, the light blue one in which we eliminate carbon dioxide emission by 2050, the sea level still rises by a full 0.5 meter. That's about 1.5 to 2 feet. And in the less optimistic scenarios, as we pump more CO2 into the atmosphere, it could rise by as much as 1 meter. There's even what's characterized as a low likelihood but high impact possibility that this melting in the Arctic and the Antarctic will destabilize some of the ice and therefore lead to an even more rapid rise, up to 1.5 or even 2 meters by the end of the century. 2 meters would be catastrophic for most of the major cities of the world. There's another consequence of adding CO2 to the atmosphere, which is not talked about nearly as much, but is tremendously consequential for the oceans, and that is increasing acidification of the ocean. The global ocean and all the creatures that live in it, from the plankton to the largest carnivorous fish, have evolved in a certain environment sensitive to a water with a certain acidity. Adding CO2 to the atmosphere means a lot of that CO2 gets dissolved in the ocean, and adding CO2 to water makes the ocean more acidic. You can see here that from 1950 to the present, we've increased by about 1/10 of a chemist's pH unit of acidity. In fact, since this is a logarithmic scale, that's a 25% increase in acidity over the last 75 years. But you can see going forward that unless we stop pumping CO2 into the atmosphere rapidly, we're going to increasingly acidify the ocean. This is highly problematic, especially for the plankton at the base of the food chain in the ocean, which have been evolved, and very sensitively so, to the current acidity of the ocean. And as acidification increases, their likelihood is that they'll go extinct. Another fiction, or at least partial fiction, is about the snows of Kilimanjaro. Al Gore loves to talk about the snows of Kilimanjaro melting away because of global warming. Well, it's certainly true that the snows on this equatorial volcanic peak in Africa are shrinking. And you can see that in the diagram where it was 20 kilometers in the late 19th century and now down to a couple of kilometers. If you want to see a white-capped mountain on the equator, the advice is to go pretty soon. But it's not because the temperature is going up on the top of Mount Kilimanjaro and all the ice is melting. In fact, as we've seen, the equatorial temperatures have changed the least compared to the Arctic temperatures, which have changed the most. What's happening here is that the ice is melting, as it always did in the dry season, but not being replenished in the rainy season because the rain patterns have changed significantly. Now, it's likely true that the rain pattern change is a consequence of global warming, but it's not simply a rise in temperature that's melting all this ice. And the final example I like to use is hurricanes. You have undoubtedly heard that hurricanes are getting more frequent and stronger as global warming proceeds. Well, everybody says that, and I used to say that too until I actually looked at the data. Facts are important in science. And so I took the period of 40 years from 1935 to 1974 inclusive and looked at the number of category 3 to 5 hurricanes. The categories of hurricanes are rated on the Saffir-Simpson scale from 1 to 5. 3 to 5 are what are called major storms. And indeed, in that first 40-year period, before Wally Broker's paper, before global warming set in, there were 100 such hurricanes in the Atlantic Ocean. In the next 40-year period, from 1975 to 2014, when we saw the rapid increase in global temperature, the number of hurricanes in categories 3 to 5 were 95. That's not bigger than 100. In fact, it's roughly the same as 100 given the random occurrence of storms. So there has been no increase in major hurricanes. In the last 5 years, we would have expected 12 such major storms, and in fact, we've had 9. So again, no evidence of an increase of category 3 to category 5 storms, storms that are categorized by their wind speed. Now, this is not to say that hurricanes haven't become more destructive over the last 50 years. They have, and they have for 3 reasons. One is the aforementioned sea level rise. As the sea level gets higher, the storm surge from a hurricane, which is highly destructive of coastal areas, gets bigger and goes further inland. Most of the damage from hurricane is in fact done by flooding, by water, not by wind. Furthermore, the warmer temperatures mean the atmosphere is capable of holding more moisture. More moisture in the atmosphere means more potential for rainfall, and as we've seen in a few recent hurricanes over the last few years, torrential rains that have led to yet further flooding and more damage and human displacement. Finally, there's a third factor in the destructiveness of hurricanes, and that is our less than well-informed policy of development in coastal areas, where if we build on the coast and hurricanes strike, destruction follows. It's time, I believe, to change the categorization of hurricanes from simply based on their wind speed to based on their destructive power. And it's also clearly time to change our coastal development policies so that we don't deliberately build new infrastructure in places that are inevitably going to get struck. In fact, if we look over long periods of time, comparable to the hundreds of thousands of years we have records for from the ice caps, then we see that it's the coldest periods on Earth that are the stormiest. The maximum of glacial extent corresponds to the maximum amount of dust and airborne debris in the Greenland ice caps, whereas the warmest periods in the last several 100,000 years correspond to the least airborne dust. That suggests that when the Earth is coldest, we have the stormiest periods, and when the Earth is warmest, we have less stormy periods. This is not to say we can stop worrying about hurricanes being destructive. They will be, and they will continue to be. But it's just that, globally speaking, the stormiest periods are in the glacial maximum, not the current period we're in of global warming.